So we're going to talk about reference angles. And a reference angles is super important when we're talking about a unit circle or whatever we're talking about, an angle of rotation that's larger than 90 degrees. Okay. So whenever I use the unit circle, I'm always going to draw my right triangle to the x-axis. And the phrase I use is, whenever you draw the angle, you're going to take an elevator down, straight down to the x-axis. So if you have an angle of 150 degrees, you're thinking, okay, well, if this is 0, this is 0 degrees, the book is closed. And then you open the book, right? This is you opening the book. And we open the book counterclockwise. That's positive. This does not look like an arrow. There, that looks like an arrow. And then you're going to stop at 150 degrees. So here's 0, and this is 180 degrees, right? So 150 degrees is somewhere here, okay? And specifically, it's right here. So I'm going to draw a little guy right here. It's this thing right here, and then I'm going to say he's 150 degrees. Okay, so when we're talking about our reference angle, so the 150 degrees, he belongs here. He belongs here, right here. That's your 150 degrees. That's what it looks like. So remember back in 4th grade, you learned about angles. You learned about acute angles, obtuse angles kind of thing. So 150 degrees in the obtuse angle, it's this guy right here. His supplement is your reference angle in this case. So I'm going to change colors. I'll use orange. This guy in here, I'm going to label him with 2. This is called your reference angle. He's the angle that finishes it to or goes back towards the x-axis. So if this is 150 degrees, what would our reference angle be in this case? If this is 150 degrees, yeah, exactly. It's 30 degrees. And in case you don't know where the 30 degrees comes from, it's 180 minus your 150 equals 230 degrees. Okay. So here your reference angle is 30 degrees. We're going to write that. Now in radians, now if you look where this lands, it's 5 pi over 6. Now we can convert this if you want to, but I'm going to show you a couple different ways to do it. Okay. So the fact that this is 30 degrees means, and this is just in my own head, so I know that pi is equal to 180, right? Oops, that's a big 0. So when I look at 30 degrees, I go 180. I go 30 degrees, and I'm going to multiply that by pi over 180. And the reason why I'm multiplying it is because this is my conversion factor. And so when I simplify this, this turns out to be pi over 6. So whenever I see this 6 denominator, I'm in the land of 30 degrees. Okay, my reference angle is probably going to be 30 degrees. My right triangle is going to be my special right triangle, 30, 60, 90. So when you see 30, think 6, as in pi over 6, which makes sense because pi is 180. 180 divided by 6 is 30 degrees, right? So this guy here is pi over 6. I think about this guy as a full pi, as in P-I-E, or pizza. Okay, so can you imagine that this pizza was cut up into 6 slices and someone had the nerve to come and take away one of my slices away? Everyone's like, wow. So how many slices do you have? Well, I had 6. Someone took away 1, and that's why it's 5 pi over 6. So it's always going to be plus 1 minus 1. So I really want you to play with this idea of pizza or pies, as in P-I-E, and plus 1 minus 1. Okay. So the reference angle for this one in radians is pi over 6. So I'm going to type that in here. It's pi over 6. Ignore this guy for now. Explain in your own words how to find your reference angle. So this is going to be really important. This is, again, that 95% when you're teaching someone else or when you're discussing and you get 70% of what you learn, right? So go ahead and write something out that gives you directions on how to do that, right? Go ahead and do that. I'll pause and I'll let you guys come back to me. Okay, so now that you're done with that, here's another one. It's 225 degrees. Obviously, it's going to be past 180 degrees. How much past 180 degrees? Well, the math behind that one is going to be, so it's somewhere here, right? Because this is 180 and this is 270. So the math behind that is going to be 225 minus 180, which in this case, it's 45 degrees. Okay, so he's smack in the middle, right? Right, he's this guy. So to convert him to radians, what we're going to do is we're going to multiply 225 degrees times pi over 180. So we're going to do all kinds of canceling. Okay, I promise. But the number that I see that they both have instantly, like right off, is I instantly see them having a 5. So you can simplify however you want. Another way that one of my students taught me was when you use the calculator, I don't know if you guys have seen this, but I want to divide 225 by 180. So 225 divided by 180 is some fraction. I want it in terms of a fraction. So you click this and it gives it to you as 5/4. So if you didn't know and you kind of want a shortcut for simplifying fractions, there you go.
Ms. Johnson?
Yes.
I thought we were supposed to multiply pi over 180 by whatever we got for the reference angle.
That's going to give you the reference angle. Oh, I see what you're saying. Yes. Yes. Sorry, I was converting this one for some reason. Thank you for that. So yes, if you did that, so then that would be 45 times pi over 180, right? And if you want to use your calculator trick again, oops, I can't be in pen mode. So then that's 45 divided by 180. And then using this, it's just 1/4. Yeah. There goes 1/4. So here, my answer is pi over 4, right? This guy here, I did want to convert this so you guys can see why it makes sense. So this one right here, when I convert it back, is 5 pi over 4. Can you think about why that makes sense? Can you think about why 5 pi over 4 actually makes sense? 5 pi, how I explained it to you. Why does that make sense? Why does this angle here? So this angle is, if you're wondering where you see 5 pi over 4, this is 5 pi over 4 here. So for some reason, you opened the book and it went past the table. Okay. And then here, if you look here, this guy in here, I'll make him orange again because that always helps. Oops, I'm not even writing in there. Oh, well, who cares? This guy in here is your pi over 4. Right? Very good. So there's your thing. Why does 5 pi over 4 make sense? Why does 5 pi over 4 make sense? Someone said, because 225 divided by 5 is 45. That's one way. Another way that I want you to keep thinking about this is if you had a pizza, like let's say I bought you guys pizza. Each pizza was 4 slices of pizza. So right here, I have 4 pi over 4 slices of pizza, right? Right here. If I open the book to the x-axis. Very good. And then you get 1 extra slice. I don't know, maybe I bought 2 pizzas and now I'm condensing. I always condense the pizza boxes. So I condense all the pizza together. And when I condense all the pizza together, I have 1 full box. And then this guy represents my 1 extra slice. Okay. So I want you to think about it in terms of that because I don't know why, but when I teach my students this, it's so much faster than using degrees, and then I can convert you over to radians much faster. So for those of you who are going off to calculus and all that other stuff, you speaking in radians fluently, think about like the way you speak English fluently, is going to help you understand calc that much better. All right, very good. Good job.